In the previous class, we studied about the hemiacetal structure of glucose, and we saw in hemiacetal structure of glucose there are 5 chiral carbons, and they are numbered from 1 to 5. And there are two forms of such a glucose. They are called alpha D glucose and beta D glucose, and they are given here. This is alpha D glucose, and this is beta D glucose. This is first carbon, 1, 2, 3, 4, 5. All these are chiral centers now, and this is the sixth carbon, CH2OH. Now here we discuss about Haworth structure. And Haworth structure is a cyclic structure of glucose, and this cyclic structure of glucose is based upon a molecule called a pyran, Pyran, pyran. Pyran is a six-membered ring. Pyran is a six-membered ring with the oxygen as the heteroatom. So there are 6 members, out of which 5 are carbon and 1 is oxygen. And based on that structure, we are going to draw the cyclic structure of glucose, that is called Haworth structure. See here you look on to this one, this ring, one oxygen, and here you have carbon. All these junctions are carbon. So this ring is your pyran ring. This is your pyran ring. Now what we have to do is, how to draw this one is quite simple if you know the structure of alpha D glucose. Remember, on the third carbon right side it is H, and on all other carbon it is OH. Actually this OH also can be represented here, no problem. So all these on the first carbon, second carbon and fourth carbon OH are on the right side. See, this is the way how you draw. This is a simple way of drawing the glucopyranose structure. Before that, how you draw the alpha D glucose structure is simple. Put a vertical line, then put 5 horizontal lines. Why 5 horizontal lines? Because each horizontal line represents a chiral center. So 1, 2, 3, 4, 5. There are 5 horizontal lines or 5 chiral centers. So you put 5 horizontal lines. I repeat, put one vertical line, then put 5 horizontal lines, and they are numbered from top to bottom as 1, 2, 4, 3, 5. And at the bottom you write CH2OH. Simply put CH2OH. Then on these horizontal lines, on the right side you put on the third carbon. On the right side you put H. On all other carbon it is OH. Then from the fifth carbon to the first carbon, you give a glycosidic linkage like this. So this will give you the hemiacetal structure of your glucose, alpha D glucose. How to draw the hemiacetal structure of beta D glucose? Simple. Put a vertical line, then put 5 horizontal lines. Horizontal lines are to show the chiral centers. There are 5 chiral centers, that's why you put 5 horizontal lines. Then what is next? At the bottom you put CH2OH. Then from carbon number 1 to 5, on the third carbon on right side you put H. See, you are going to draw the beta D glucose. What is the difference between alpha D glucose and beta D glucose? They are anomers. The only difference is on the orientation on the first carbon. So since you are drawing the beta D glucose on the first carbon, the OH must be on the left side. OH is on the left side. Then from the fifth carbon to the first carbon, you put a glycosidic linkage through oxygen atom. So this is the hemiacetal structure of the alpha D glucose and beta D glucose. Once if you understood to draw the hemiacetal structure of alpha D glucose and beta D glucose, so what you have to do is you try by yourself. you took a piece of paper and a pen, then you just follow what I instructed earlier. Just put vertical line, then 5 horizontal line. Then on the third carbon on the right side you put H. Then from the fifth carbon to the first carbon there is a glycoside linkage. On the bottom you put CH2OH. And if it is alpha D glucose on the first carbon, OH is right side. If it is beta on the first carbon, the OH must be on the left side. Very easily you can draw the Haworth the hemiacetal structure. Once you are familiar with the hemiacetal structure, you have to try once or twice by drawing it. Then it becomes quite easy. No need to buy hot and roll. Now, see, I hope you know this, how to draw this structure. Then it is quite easy to draw the Haworth structure. First, you put this circle and then this hexagon. This hexagon including one oxygen atom. Now you start from this point. Actually, here you are going to select 6 atoms. 6 atoms. One is oxygen. Then you move in anti-clockwise direction. You are moving from this oxygen. You are moving in anti-clockwise direction. Then this is the first carbon, second carbon, third carbon, fourth and fifth carbon. Remember, in pyrene, it was a 6-membered ring, out of which there are 5 carbon and 1 oxygen. And here we are selecting carbon number 1 to 5 and this oxygen for this pyrene ring. So you have to go in an anti-clockwise direction. So anti-clockwise direction, from oxygen you will met first carbon, second, third, fourth and fifth. So here, from this oxygen, you have to move in a clockwise direction. Whatever you pick up from here, you have to draw here in an clockwise direction. That means this is your first carbon, this is second, this is third, and this is fourth, and this is fifth. So once again, this is in a clockwise manner. First, second, third, fourth, and fifth. And at the topmost you put CH2OH. Then in each carbon, 1, 2, 3, 4, 5 numbered on the apex of the hexagon, you put a line. You just draw a line perpendicular to this one. Simply draw a line perpendicular to this one. Now whatever you have here on the right side, you put below the plane, and whatever you have on the left you put above the plane. So no need to refer this figure. Very easily you can get. No need to refer this one. Very easily you can get. Remember, you are drawing the glucose. So on the third carbon, I am not referring to this whatever drawn here. Simply I am recollecting from my memory. On your glucose, on the third carbon, right side it is H. So what you do is, on the third carbon, below the plane, you put hydrogen. And since you are drawing the alpha on the first carbon, OH must be below. And of course, on the second and third, fourth, the OH is below because they are on the right side, second and fourth. So you will get what is, and all others you can put very easily above the plane. So very easily you can draw the alpha D glucopyranose. Why it is called pyranose structure? Because it is with reference to the pyrene, molecule pyrene. Now how you draw the beta D glucose? First you put hexagon with 1 oxygen atom on the ring or on the hexagon. Then you move it here in anti-clockwise. So here you meet 1, 2, 3, 4, 5, 6. I'm sorry, 1, 2, 3, 4, 5 in anti-clockwise. You reproduce them here in a clockwise manner. So this is 1, 2, 3, 4, 5. And each carbon you put a perpendicular line. And whatever here you have on the right side, you put below the plane. So on the third carbon, it is hydrogen on the right side. So here you put on below the plane. On second, fourth, it is right side the OH. So it is below the plane. On the first carbon, right side, it is H because it is beta. Beta isomer. So on the sixth carbon, you put CH2OH at the top. And on the fifth carbon, you put CH2OH at the top. So this is the way how to draw the pyranose structure very easily. you just go through this lecture once or twice so that it becomes very easy for you to draw, and you try by yourself in your home, so it becomes easier. And if you feel any difficulty to draw, you can make a call. Please try to make the call in the evening after 7:30. I'm busy with admission, so it becomes easier. If any difficulty you feel, I will tell you how to draw it much more easily. Okay, thank you. We'll continue the discussion.